coming back to school tomorrow.
I
Okay,
can
we'll see you later. Go ahead and, okay.
Whoa!
So, welcome Jamie as a sign up. Alright, so before you watch the rest of the lesson, Jamie, I need you to go to your parents and have them take a photo of your homework and then email it to me. Everyone else in the class, hand it to me as you go by, because this one is a graded one. So if you have to awkwardly tear it out, I'm sorry to awkwardly tear it out. Thank you. Alright.
I did not actually seriously do it.
Of course you did. You never
That's
did.
a really big bummer, Chris. That's one of the reasons why you want to try it as we go through it. But yeah, but this homework should have been pretty straightforward. So even if you don't know the answers, we're going to go over them in class, because I literally just stole your homework. But it's a good practice in class to be able to go over. So let's go over that question one first. Let's go over that one first. So what are delocalized electrons? We've already talked about that enough in class, where that one should have been a pretty easy idea for it. So what is delocalized electrons? Alright, Quentin.
Delocalized electrons are electrons shared by two atoms.
Yeah, so like two or more, but it's basically they're not locked in, so they don't have a home.
I
So
thought
they're
they were
basically
unwanted. I put unwanted. Does that count?
That's what it's called.
I'll probably count that because you have the right idea for it. But again, you want to go off the textbook definition, but yeah, I mean you have the right concept of
put
it.
right.
Wait, I can only do one person talking at one time. Okay, so Chris first and then
Are
you.
we recording?
Yeah, we're
You're
good.
telling her the answers to the homework. What if she didn't do the
That's
homework?
why I said to stop
It's
before you watch the
Jamie.
rest of the video to take a photo
Why
of
would
it
she
and
do
email
that?
it
She
to
get
me.
the easy 100 on her homework.
Because
It's
Jamie
Jamie.
is a good, honest
It is
person.
Jamie.
Hi,
Never mind.
Jamie. Okay,
You
so
better be
that's probably the
talking
reason why. But again, I mean, for those of
We
you
were
that
all
watch
there.
my videos while you were at home, whenever we did the video, the 3-week ones, I would do the review in class and then tell you to pause your video and then go get the quiz and stuff out. So yeah.
Yeah. I did them all on Monday, so I'm joking.
But again, that's the reason why it's
So they're
where
$100.
it's an understanding between me and your parents that that you're not cheating for it. Okay, we gotta move on.
Oh,
All right.
I'm really sad when we don't get that.
Alright, we gotta keep going. Alright, so let's look over onto the next section for it. So again, we're gonna talk through these and I'm gonna write them on the board so since I stole your homework from you. Alright, so for this first one, so letter E is xenon and fluoride. So that one's a metal and someone is I said metal. Non-metal and a non-metal. So if it's a non-metal and a non-metal, what type of bond is that? Ionic, covalent, metallic, alright?
Covalent, right?
It is covalent. It's a
There's one.
non-metal and a
I got that
non-metal.
one wrong.
Alright, so the next one is iron. So it's just a metal. So what type of bond holds the metal together? Wait, we're gonna take turns. Alright, what type of bond holds metal together? Metallic.
Got that one wrong.
Alright, number G.
Really?
That one is a metal and a non-metal. So if it's a metal and a non-metal. Alright, Chris, what type of bond is it?
Ionic.
It's
I got that
iron.
one
Should've got all these
wrong. I
right.
got that one wrong too.
Just give Chris a zero at this point.
Ooh, it's gonna be sad. But again, the reason why you want to try it and actually put some good
I
solid
can't believe all
effort
that.
I haven't done that in the entire 2 years I've been at this school.
Maybe I should do homework checks more often.
Yes.
More like homework.
Good.
To me, it's April 1st.
Great,
Alright,
every
let's
single
keep
homework.
going. Alright, letter H for it. So that one is a non-metal and a non-metal for it. So what type of bond is that?
Say which one?
Letter H. So
That's the metal and non-metal?
it's a
I
non-metal
know,
and
but
non-metal
yeah.
because it's hydrogen, C, and then nitrogen. So all of those are non-metals. So it's a non-metal. So it's a bunch of non-metals bonded together. So what do you call that when it's a bunch of non-metals together?
Alright.
You sure?
Mm-hmm.
Because it's a bunch of metals. I mean, it's a bunch of non-metals.
That's what I thought.
It's close. What?
Covalent.
Covalent because
Still, I
it's all
got that one right.
I thought
non-metals.
covalent
I
was
know I got that one.
non-metal.
What?
I thought covalent was non-metal and metal.
They're not metal. Okay, which one of those is the metals?
None of them. That's why it's
Okay,
ionic.
covalent is for non-metals. Covalent is a non-metal to a non-metal.
I did not know
Ionic.
that one.
Ionic is.
We're not doing H.
Can't wait for a gay bird.
No, I'll look at them later. No, I'll look at them later.
Alright.
I'll grade them later. Alright, letter I. So aluminum and oxygen. So that is a metal and a non-metal. Alright, Chris. Well, now that we're fixing it, so a metal and a non-metal. That one's ionic. Alright, potassium chloride. That's a metal and a non-metal. So that one is ionic. Alright,
So wait.
oxygen just bonded together.
E, remember, go back on E, that you said that was covalent, right?
Mhm.
That's a non-metal and a metal, right?
That's a non-metal and a non-metal. Xenon and fluoride. So xenon's here. Fluoride's here.
How do you know fluoride's not a metal?
Fluoride's here. Because it's on the right side of the periodic table. You learned this previously, Chris?
I also ate a lot of turkey and it broadened my brain.
That was like 4 days ago.
Today's 4 about 740.
What were you looking at?
I was like, looking at freckles.
I don't got freckles on my. Actually, I do have freckles on my.
Alright, so let's keep going. Alright, so oxygen to oxygen. So if you have just like a diatomic molecule where oxygen is bonded to itself, which one is that? Alright, Chris? That's covalent. Alright, and then chromium. So if you have just a bar of chromium, basically, what is that? Okay. It's just metal. Metallic. So that one is just metal. Alright, we'll go through. So hopefully as we talk through them, it makes more sense. Nope.
Can I just look at it? I won't change it. I just want to look at it. Please. I'll put all my stuff away.
What if we put like everything?
What?
Everything. Like we don't have anything.
You
We
don't
can't
have
change hands, we just look at it.
No, you'll find out later. It'll be okay. But I don't want you to get depressed right this
I might
second.
as well.
I'm already depressed. You
Sorry.
took my will to live.
I'm sorry. Alright, gotta keep going. Number 5. Tell whether the bonds between the following atoms are polar or non-polar. You have 50
I
shot,
have no idea how to
basically.
do these, so I have to 50 shot anyway. Even my next round.
Alright, so you have silicon bonded to silicon. So Chris, I'll help you out. So if it's the same substance bonded to itself, will it be equal sharing or unequal
Polar.
sharing?
Equal.
Equal sharing. So is that non-polar or polar?
Polar.
So polar means
So D is polar?
Wait. Let me play it first.
Oh, no.
So,
Non-polar.
yes, it's non-polar because they have equal sharing. No one's winning. So that first one is non-polar. Alright, hydrogen and oxygen. It's
We
like,
didn't get that though.
what?
We didn't get it right.
Oh, I'm so sorry. It was D through H. Alright, so
Did you do the extra homework?
carbon and oxygen.
A through
So
H.
wait, stop. I can't focus on everyone at once. So it was D through H. So carbon and oxygen. So is that equal sharing or unequal sharing? That one is unequal. So is that polar or non-polar? Polar. Alright, chlorine and fluoride. Oh wait, chlorine and fluorine. So Ethan, is that one polar or, well, first of all, is that equal sharing or unequal sharing?
Unequal.
So polar or non-polar? What?
Polar.
Polar. Alright, chlorine to chlorine.
I gotta do that thing.
Is that equal sharing or unequal sharing?
It's not full.
It is not polar. Why?
Equal share.
Good job. Alright, nitrogen to hydrogen. Equal sharing or non-equal sharing? Ethan.
Did you put polar on this?
Ethan, answer the question. G. So is that one equal sharing or not equal sharing?
Polar.
Okay, well, is it equal sharing or not equal sharing?
Unequal.
Okay, so it is polar. You're right, right? Alright, oxygen to oxygen. Alright, Quentin. Non-polar. Why? It is equal
At
sharing.
least you know you got half of them right.
Maybe college ain't for me, man.
It's okay. So if you learn from this and if you decide, maybe I should work or try a little bit harder, then that's okay. Just
You
make
should
sure that
grade.
you learn it. Oh no, I'm great.
Grade on
I'll give you $20
What?
and
No.
I'll buy you McDonald's.
No.
Okay.
Grade every single homework. You could do that for me.
That we have for the rest
So
of the year.
much work. Well, some of it is math, and I want you to do honest intent for it. So I don't want, but these should have been straightforward because it's literally just saying which one is which. And I've asked in class. Wait. And I've asked in class if you needed help. So it's one of those to make sure, and it was literally 50-50
You
for
said
number
you
5.
were probably going to grade them too.
Yes, and you
I
still did it
basically
wrong.
did. So it's one of
I thought
those.
you
You
were
just need to
pulling my
be.
lariat.
No.
Well,
Just keep in mind, U.S. history is later. So if you realize you made poor life decision now, then
I
you
got
know.
them all right.
Are you grading U.S. history?
Maybe I can grade whatever I want.
Thank you.
I like forward tenses.
What?
All of them.
You're at what?
Forward tenses on all of them.
You might want to fix that.
Really?
If not, in U.S.
We have less
history.
time.
Just saying. Not saying I am going to grade it, but I'm saying
Grade
you
it.
need to be
Grade it.
aware, just in case,
Grade it.
because I can always grade it if I want
Play
to.
the dark game.
What?
Grade it.
We tried dark game.
Can you do it quickly?
Yes.
We always do. We're so fast.
Okay, you all have to remind me, and I'm sorry, Jamie, and I'm gonna apologize again in U.S. history, but Jamie was stuck staring at the floor the whole U.S. history class, because I forgot.
Really?
So,
The entire
yes,
U.S. history.
yes, except like the last 3 minutes of class. I don't know what happened, I'm sorry, Jamie, again, I must have bumped it after I said it. Well, yeah, that too. But it's one of those where I thought I fixed it, and I guess I bumped it. I'm sorry, Jamie. So she was stuck staring at like Ted's feet the entire time, and I'm very sorry. So if we play the dark game, you guys have to remind me to fix the camera so Jamie's not stuck staring at the ceiling for the rest of the
I
class
get
period.
candy if I'm hungry.
No, but just help me to remember so that way Jamie's
That's
not
cool.
stuck. I'm sorry, Jamie. I will try to remember it, and the gentlemen are going to try to remember it as well. Sorry, Jamie. Alright, so get that piece of paper so you write down stuff you don't know as we go through this section.
already have one.
Alright, just make sure you have one for it, and add a piece of paper or pen. Alright, so I think sure we went yesterday, so we'll just rotate around and we'll go over to Chris first for it. Alright, Chris, so what, if you have a metal to a metal, what type of chemical bond is that?
Metallic.
That is metallic. Good job.
I cleaned the desk. I didn't touch my face. Oh.
He does.
what they're marking.
Yep, gonna use those
It's
later.
funny how I went
Okay.
from no
A
vaccine
little
to
bit.
vaccine. And like, hey,
Hey!
all the way down. It's gonna fall off.
So,
It's
Just
gonna
be
fall
careful.
off.
Hey, 11. So at least you have points, Chris. So that's
Okay.
good. Alright,
you got
Ethan's
my
turn.
number?
Alright, Ethan, if it is a non-metal to a non-metal, which one is that? Let's not do that. Bring it over here so we're still playing.
What's the
Solid.
other electricity?
There's 3 different types of bonds. If it's between a non-metal and a non-metal,
Savannah,
that is covalent. Non-metal to a non-metal.
Is that one you missed?
probably. That's everything.
You missed everything.
No, he missed everything.
Hey, that was a good arch.
Yeah, that's a good
That's
arch.
14.
Don't touch
That's
it.
one.
That's 14. That's one.
That's 14.
It is on the
That's
line.
one.
So you can either keep the 1 or be.
Forget one. Even if I get 0, I don't want one. Huh?
Oh, that's so old. Alright, Quinn's turn. Alright, Quinn, if it's between a metal and a metal, that's metallic.
I would never do this, obviously.
Right here? Right here.
Yummy!
I believe it's, I think it's this one. So it's supposed to be the end
Alright,
of
okay,
that.
my nose starting again.
No.
I didn't even take
Okay, if
it.
it falls, we got
I'll take
17.
17. No, you all.
Alright, Chris' turn. Alright, Chris. So, which one is characterized by the exchanging of electrons? One of them's throwing it, one of them's taking it. Which bond?
Let's start with
It's between ionic, covalent, and metallic.
Stadium.
So one of them's giving up an electron, one of them's taking it. Or more than one electron.
Metallic.
Metallic final answer?
No. Covalent.
Final answer?
Yes.
No! Alright, so first person to steal. If you want to try to steal it back, you can. So, remember, one of them's giving up an electron, one of them's taking it. So what type of bond is that? Go!
Ionic.
Other one is ionic, because that's one between the metals and the non-metals. Because one of them's throwing away their electrons, one of them's taking it.
Fine. It's quick.
Good.
Yeah. Oh.
That's on the line.
That's close.
Yeah, so you can either keep 9 or rethrow. Just keep
I'll
nine.
redraw.
So you got 4, and you get 1 more.
You're really messed up. See, that's why you're messed up.
Alright, it's Ethan's turn now. Alright, Ethan, which one is characterized by a sea of electrons? Nobody wants it, so they're all getting shoved away.
Covalent.
Final answer? Nope, it's not covalent. Alright, first person to raise your
Ah!
hand. Nobody wants the electrons, they're all getting shoved away. What type of bond is that? Go! Who wants Chris? What was it?
Delocalized.
Okay, no, what type of bond? What type, you're right there, delocalized, but what type of bond? Ionic, covalent, metallic, there's no bond.
Metallic.
Final answer?
Yes.
Yes, it is. Metallic. Because it's
What? You
delocalized.
get 2 answers?
You is right though, where we call the electrons delocalized electrons, because that's one type of bond. Ooh.
Great. Great, that's 3.
That's 19.
Wait, let me look at it.
Or
Okay.
is it?
It is predominantly on 19.
Predominantly.
Dominant.
I'm predominantly.
I'm Joe Biden.
Yeah, I think it'll stick on the screws, but not on these poles. These poles are aluminum. Alright, which one is characterized by the sharing of electrons? So it's Quentin's turn officially now. So they both hang on to it. Okay, let's not do that again.
That was nice.
Let's not do
Can I
that
get it?
again. You may get it.
That was nice.
Just be careful. It was an accident. Alright, which one is characterized? Final answer?
Yes.
No, which is characterized by the sharing of electrons because they both hang on to it.
Oh.
Turn on, turn. Go.
Covalent.
Covalent, so they both hang on to them.
Imagine if you got it wrong.
That'd be very sad. Hey, good job. Alright, back over to Chris. Alright, Chris, if I put, we'll say, xenon and fluoride together, like that. Alright, what type of bonding is that?
They're both non-metal.
They're both metals.
So,
Ooh,
covalent.
covalent. Just making sure.
Throw 'em
If you want to, that's your toss.
It's a ball.
Alright, so potassium fluoride, Ethan, what type of bonding is
I'm gonna
that?
stick this in your ear and it's gonna stick too.
Peanut. Peanut. Alright, potassium fluoride, what type of bonding is that?
Ionic.
Final answer? Good job, because it's between a metal and a non-metal.
I probably got that one wrong.
I don't think that one's straight out of your homework.
Hey, he said the edge.
No, I did not. It's right there.
Please.
Wait.
That didn't count.
Wait. No, it doesn't. You gave free throw.
The 12 doesn't count either because he said
No, I did not. I threw it before I went over.
Where'd you stand?
I threw it before I went over. I threw it
That's
before.
mad
It's
sus.
not right there. It's right there.
You're sus.
Is it?
It was over there.
I told
That's
you.
where everybody was going.
No, didn't I tell you it's this one?
Yeah.
No, you didn't. It was right there.
I'm sorry, it's this one now.
Just throw.
There you go, throw. You may keep the 12 because of unknown. Ooh.
Online. That's 14.
It's on the line, Ethan. Where are you getting 14?
That's
It was on 14.
18. Yeah, it's 18, okay?
Wait, you come to this line, because it's the edge of your desk. Okay. Not bad.
6.
Alright,
Nine.
so it's your turn. Let's see. Let's say I have a pure bar of gold.
It was
Then you're
Metallic.
A full like pure ball or bar of gold is like $1 million.
It, depending
Well,
on how
it depends on the
large
carat.
it is.
It also depends on the carat.
Ooh. Yeah. I'm very sorry.
That's in between 3 of them.
That's 2.
That's between
That's
like
2.
25 and all of them.
That's 2.
That's 15, because it's predominantly in
Alright.
that spot. And
No,
it's so
it's
steep.
not.
I'll take it.
No.
You have more than 30.
Yes.
There you go.
Alright, what rule says I have a tendency to
Should I
try to
do it?
get the 8 valence
What
electron?
is that?
What?
Octet.
Octet.
Go.
How much it up, man? Okay.
I want to cry, dude.
I'm
gonna go home.
He's like, I'm gonna head out.
I'm gonna go home and I'm gonna get a tattoo of just a dart falling off the board of my arm.
Alright, what do you call an attractive force between atoms that is strong enough to enable them to act together as a unit?
He threw it at me.
Me too.
Or D.
What?
Alright, what do you call an attractive force that binds the atoms of a molecule together?
Sorry.
What?
C.
Covalent network.
Because there's 3 different types of this. There's ionic, covalent, metallic. What do we call those?
Sure.
Starts with C.
2 words.
2 words.
What is the other word from?
Starts with
If
B.
you don't get this, I'm
Covalent bonding.
Okay, covalent bonding is a type of this. So ionic, covalent, metallic are all examples of what?
Chemical bonds.
There you go, chemical bonds.
I just remember that one.
You get it.
No, I remember that one
Yes.
last second. Wait, it's right here.
It's right there.
It's at the edge of your desk.
Sorry.
Okay.
Bruh.
Might fall off though.
Yeah.
My phone
No,
don't
Chris.
go long.
Hey, good job.
8 and 3.
8, 17.
Alright,
Get more than
what is the most important factor to determine how an atom bonds?
The dad.
No.
Valence electron.
Okay, I'll take that. That works. The number of valence electrons.
What's it like?
Probably didn't like me. I'm quite cheated, so
That's all.
I saw that you agreed with you.
It's not like an emo
Alright,
kind of Star
what
Wars.
actually holds the ionic bond, put it that way. So, because one of them's throwing away an electron, one of them's taking it, what actually makes them stick together?
Let's start with
See, I guess.
covalent.
Okay, ionic bonding. So what makes them stick together? Because one of them threw away the electron, one of them took it. So it's not the electrons holding them together. What's holding them together?
Covalent bonds. Is that what you're asking? It starts with the what?
Okay, it's an ionic bond.
Okay.
So what makes them stick together? What's causing like I erased it.
What's
Ions?
What's causing like potassium to stick to
Let's
fluoride?
start with.
C, I guess. Maybe an E. depending
Oh,
on which
yeah.
one you're using
Is it
for.
electrons?
Not electrons, because one of them's
Is it
chunking it.
ions?
Ions, remember. Okay, ions, remember that they have a charge.
Yeah, ions?
Kind of a positive one.
This is what you're at. Like,
What makes potassium stick to fluoride?
they have 8 electrons.
Okay, potassium just yeeted cheated off one of its electrons and fluoride took it. So what makes them stick together? Why does the potassium just go, bye, you took my fluorine. I mean, sorry, you took my electron. Not poles.
And it causes
You have like all around it, you just haven't hit the right thing for it. Starts with C or an E, depending on how you're gonna say it.
It just sounds weird.
Not really.
Is it chemicals on it?
Alright, first person to raise your hand, so what?
Covalent.
First person to raise your hand. Go. Alright, Ethan.
Charged electrons. Electrons are charged.
You're going with charged electrons.
That's what you said yesterday. Electrons are charged.
You're half right.
Charged ions.
Yes. Because this one has a positive charge now, this one has a negative charge.
How would
So
you say that
charge-
with an E?
Electric charge. I mean, that's the only other way to put that.
Electric
So,
type Pokemon?
yes, that's what I didn't want. So either electrical charge
Ground
or
type.
charge. That's what holding this, the
Ground.
ions that make them stick together.
I hate it.
I'm built like Wailord.
I hate it. No, you build like.
Or wax.
Don't be as nice.
Built like some
Don't be
king.
as nice.
You're built like
Oh,
some
no.
king.
Okay, as long as you're being nice.
No, you build like.
That's 12 or 9. That's 12.
Who?
That's 12 or 9. That's
That's
predominant.
12. It's predominantly on 12.
It's okay, you're gassy.
It's okay, you're slicking.
As long as y'all are being
Slow
nice.
down.
Alright, it's Ethan's turn for real now. Alright, Ethan.
Oh yeah, let's go.
It's okay, you're.
Alright, y'all are slowing me down. Alright, what holds a covalent bond together?
What's our
S, I guess, or E, depending on how you say it. Covalent bond. Okay, what's the characteristic of a covalent bond?
Holds
What?
non-metals and non-metals together.
Okay, non together.
They write one on board.
This would happen. Right up higher so Jamie can see it. I've forgotten, Jamie.
So.
What makes them stick together? So over here in the ionic bond, it's because it's the charge is holding them together. What makes them stick together?
Let's start with the end.
I would guess E or C, depending on how you, E or S, depending on how you say it. What makes
Charged
them
electrons.
No. Alright, refrigerator, raise your hand. Go. Alright, what's the characteristic of covalent bond?
COVID?
No.
No,
Covalent bond.
non-metals and non-metals.
Non-metals, and then if you're talking about the electrons, what's the characteristic of it? Because ionic is one of them throwing it away, one of them taking it. What's the characteristic of covalent?
Positive.
How about the negative? The fact that they're both
Localized.
sharing electrons, or both of them are hanging on to it. That's the reason why. So sharing of electrons, both of them are hanging on to their electrons, so that's why they're stuck together, because both of them are attracted to it.
We have to know this.
Yep. We're gonna have I believe it's an entire, like, matching section. This might even be on the exam,
easy.
where it's like, okay, what's the characteristics of it? Which one goes to which? So non-metal to non-metal,
easy,
metal to
yeah.
metal.
Yeah.
It should be easy, but if you don't know this stuff, then you're gonna sit there and kinda wanna cry. So make sure that you know it before the
What are
exam.
those are covalent and
Okay, so,
ionic.
metal and non-metal, so which one?
Ionic.
Okay, non-metal or non-metal?
Covalent.
Covalent. Alright, so, nobody got it, so.
Ethan's turn.
Yeah, we read that.
No one knew, we'll go. Alright, Quentin.
Oh.
Alright, Quentin,
That's
so if I have, right, so what? Okay, I think that one might be too hard, but we did talk about this yesterday. What do we call the electrons where nobody wants them in the metallic ones?
Ethan.
So they stick together because they're all the same substance. Delocalized electrons.
Why would that be too hard?
I don't know why they're.
That's
That's all we did when we learned yesterday.
Yeah, well, because I was gonna ask originally what makes them stick together, but it's because like they're all the same substance.
Bro! I went from 18 to nothing.
At least you
One.
got one. You got
Let's
one.
go, Quentin.
Alright, if I have a single covalent bond, how many electrons? Alright, good job, Chris.
COVID.
I like to go.
Wait, what was the answer?
Single covalent bond, how many electrons?
Wait, which one keeps sliding? I think it's the blue one.
No, it's the red.
Yeah, I think it's the blue one.
I I try to keep them on the metal so that way they will like reach.
At first it was the blue ones that
Yeah,
were
like
good,
Yeah.
and now it's the red ones.
Did you realize though if you throw them too hard that can affect the magnetism, so that might be part of the reason why they're getting messed up. Watch out for my board. Alright,
They stick to
if I have a double covalent bond, how many electrons are being shared?
4.
You're done. I'm gonna skip triple, I'm sorry.
Any party?
Sorry, Mark. You're not low.
Come on back, Chris.
It's not fair.
You're gonna get hit.
Block it.
Don't wanna hit you.
You know. 13. I want that 13.
Like you hit me in the head as I was walking
Yeah,
out.
that'd be
Is that
fun.
115? Oh, that's from yesterday. Oh, okay. Okay.
Wow.
25 points.
Where to hit that though?
That's 13, right?
Yep, 13. Predominantly 13.
Let's go!
Alright, give an example of a covalent network.
COVID.
One of them starts with D, one of them starts with
I don't know.
Alright, raise your hand, give an example of a covalent network. One of them starts with D, one of them starts with a Q. Go.
Five.
Diamond or quartz. Diamond or quartz.
Diamonds!
Or quartz.
I'm never going to I'm going to just cause it's so weak.
If I write Minecraft rubber ducks, does that count as corn?
Absolutely not.
What was that?
It tried, and then decided it didn't want to after all.
16!
Slide.
Alright, give a characteristic of a metal we talked about. Because none of them want their electrons, what's a characteristic of a particular metal?
What do you have, 5?
They can, no, I'm 30.
Oh.
They conduct electricity.
You don't know electricity you need.
You only have 30? Yeah. Oh, okay. What do you have, then?
I say love of my darkness.
I have to add them together when. I'm not doing it.
Oh,
You can't add
But there's
together.
are my points. That's two.
that's two.
I'm still gonna lose probably.
Two
Yeah,
is
because I'm a
good.
little ego-pinky.
Alright.
I'm still gonna win.
Alright, if I have equal sharing between an atom, well, between molecule, what must say? Absolutely not. If you hit me, yes.
Ah.
Don't do that.
That's not
Take it
cool.
off. Take it off. Alright, if I have equal sharing between the atoms in a molecule, what do we call that? Okay, it's covalent because it's sharing, but what do we call it in particular?
What did Chris say?
Equal
This
sharing.
isn't even the same. Oh, Chris's answer wasn't the same thing?
Nope.
Okay, so equal sharing between what's sound?
If I have equal sharing, like from chlorine to chlorine, what do we call that if there's
Oh,
equal sharing?
non-polar.
Non-polar. Listen, this is not supposed to be super hard.
Throw both of them at the same time. You will.
I know.
What's a very
I should
hard-
throw it at the same time. Should throw it at the same time.
Alright, so if I have two different atoms bonded together for this unequal sharing, what do we call that?
Oh.
That's polar.
Oh, it's review day for math and
Oh, that's cool. Alright, so since this is sharing, we'll say between like hydrogen and chlorine. Alright, so since chlorine has most of it, but it didn't take it all the way, so what do we call that? Or what symbol do we use to represent that? I'll take either part of it. P, I don't know how to like say like
Is
this.
it like a reverse delta thing you're talking about?
Not reverse delta.
It's something to do with delta?
Yes.
Is it just delta?
Well, remember, capital delta is the
Oh,
triangle.
lowercase delta.
Lowercase delta. So it's the partial charge to represent this one's partial positive, this one's partial negative.
I'm throwing both of them.
Okay.
Who was that?
Careful.
You okay?
Shot for 10.
Or-
Hey!
Two!
You got 4, so that's
That was actually
good.
kind of good.
Alright,
4.
what do we call a molecule
Why did
like
that work?
this, Ethan, to where you have a partial positive and partial negative, so you have two sides basically of the molecule, or two charges, what do we call that on the molecule?
Double charge.
It's not double charge.
Star.
What's the prefix that means two?
Die.
Di, and then on a
Dicharge?
magnet, what?
Die charge.
Close. On a magnet, what do we call like the north and the south?
Dipolarization.
Close enough. Dipole. So dipole is a two-sided molecule.
I love that song.
That's 2.
That's all.
Sorry.
That's 2. That's all.
There you who does?
That's on the line. No. Bears on the line.
It's predominantly
You want to take two?
off.
No,
He can take two. He can take two.
It's too off, Ethan. If I'm gonna count another one, I have to count that as off.
You might have to
Alright.
say right here.
Let's see. Alright, what do we
I
call?
hate two.
I guess the diagram is the best way to say that. Whenever you're drawing, like, that's a weird accent. Whenever you're drawing the molecule, what do we call it?
What is that?
L?
Is it name?
Yes.
Lucas?
Lewis?
Okay.
Good job. Yeah, it's just the idea of this one is showing a whole
You're at Lewis
molecule.
symbol, are you wrong?
Lewis symbol is technically like the
Two
atom.
different things.
Yeah.
Oh.
I mean, it's the same idea.
Whoa, whoa!
It's like a 3-point shot.
He's trying.
Just a little too high.
Who has 50 or more? We
Me.
went through a
Me.
bunch.
I do.
Okay, 50 or more, okay. Who has 75 or more? Because we did go through a lot.
Do you want to say
I
that
have
right?
65.
I have 103.
Good job.
I had 36.
I'm sorry. Alright, turn over to page 136. Alright, that was a good long review. So, if we were to have a quiz tomorrow over the types of bonding, thank you, over the types of bonding and what they mean and the characteristics are saying, hey, here's a molecule, what type of bond is there? Does anyone feel the need to go over it again? Or is everyone okay and understanding of what they're
Better
supposed to
review
do?
tomorrow.
We'll review tomorrow, but they don't have any questions now where we're like, say, okay, this is between a metal and a metal. What type of bonding is that?
9.
Okay, we'll
Okay.
move on from it. Alright, so page 136 is where we left off, talking about delocalized electrons. Alright, so delocalized electrons we've already kind of talked about with the idea of metals, because remember, why do they not want their electrons? Alright, Quentin.
Because.
Alright, most metals have how many electrons? Loosely. Yeah, 1 or 2. So which is easier? Gain 7 or 6 or lose 1 or 2? Lose 1 or 2, so that's why all of them go yeet, basically, because they don't want them, because it's easier just to get rid of them that way. So a delocalized electron, make a note of that term on page 136. These are electrons that circulate freely throughout the molecule instead of being bound to a single atom or a pair of atoms. So basically no one wants them. If you write down they're not locked in or they're not designated to a single bond, okay, that's the idea. So yeah, you can make lots of sad analogies. If it helps you think of a sad analogy, that's fine. But just make sure that you know the definition. So if you see it on a quiz or test, you can match it up. Alright, a bonding situation in which the electrons are shared by more than 2 atoms, that situation is called delocalization. So the terms are super close to each other. There's delocalized electrons, so that's like the adjective one if you're talking about the electrons. If you're talking about the situation, that is delocalization. So just be careful that you know, okay, it's delocalized electrons, not delocalization electrons. So just be careful that you know which one you're talking about for it. Alright, in some cases, you can have the electrons, but it looks like that they're vibrating or hopping back and forth between them. We call that resonance as well for it. Your book gives you the example at the top of the page where it's showing you between oxygen and sulfur that, you could write it as one way or the other way at the top of the page, but it's saying, okay, typically those extra 2 electrons, they're not locked into one spot or the other spot, they're vibrating or floating back and forth between them. They're not locked in. So those a pair of delocalized electrons, they're hopping back and forth between this. We see this also in ozone and benzene as well. So we'll talk more about benzene whenever we talk about hydrocarbons way later. Anyone know what ozone is though?
The layer that
Ooh, raise your hand. Yes.
layer that takes from the sun.
Do you know like where ozone comes from? I don't think you've read about this in your book yet.
Where's the name?
Yeah, like where does ozone come? Like I could make ozone in the room if I wanted to right now. I just
It's
don't
a
want
mix
to.
of different chemicals like nitrogen, stuff like that, isn't it?
What's the chemical formula of ozone at the top of the page? Okay, top of the page, page 137, you see B, delocalized electrons and other compounds.
O3.
O3, so it's oxygen, but what causes oxygen to do it? Because remember, most of the time, oxygen, gotta stop moving chalk, oxygen is like this, where it's diatomic. So does anyone know what causes it to do this way? Remember, it's delocalized electrons?
It's gotta be that way.
Okay, it does it in a certain circumstance. It does it with the energy from the sun and with those high charges, you can make ozone. Don't do this all the time, but you know how like whenever like you plug in or whenever you plug something into a socket or pull it out slowly, it makes that spark and it makes that weird kind of like metallic kind of sparky smell. That's ozone. You generated a little bit in that little environment for it. So that's the reason why we would say like sockets have like a certain smell, is because you're smelling ozone right then. Now it's not dangerous, you can breathe it, you'll be fine. But again, don't breathe it all the time because your body can't use this type of oxygen, gotta have this one. So again, if you just breathe in just pure ozone, okay, now you're in trouble. That's one of those where, okay, if you just breathe it in a little bit, you're not gonna die or anything. But it's generated by like high energy way up above the earth with like the UV light. And that's the reason why it helps protect it. Alright, are you raising your hand anything? I'm just gonna talk. Okay. So, we call that delocalization. So, your book points out though, whenever you have a molecule with a Lewis structure, could be written two different ways. They write it sometimes showing it with a double arrow. Like for example, if you do the one with sulfur and oxygen again, stay shock. So, looking at this one at the top of the page for it, that it says that okay, you could write it like this and write the dots around it. And because of that, you can have sulfur be satisfied and each of the oxygens satisfied. But because of that, these localized electrons, they technically hop back and forth between them. And so because of that, they'll draw a double arrow, just help say. It also does it the other way as well, where this one has the double bond. So it's just showing you that technically it's vibrating or hopping back and forth between them. Sometimes they'll put them in brackets as well. That's what it's showing you with the NO3. Does anyone remember what that ion is called? Or it's the NO3 ion?
Nitrogen oxide.
Okay, remember it's an ion, so we have a special name for it.
Nitrogen trioxide.
Nitrogen. It's an ion. So it's from that chart way back on page like 42.
Is it ammonium?
Not ammonium. That's NH4, I believe.
Arsol.
Nope. Alright, so this one is just nitrate. But just make sure that you're going back and that you're looking over them. Just remember, exam is everything up till now at Christmas. So just make sure you're going back and reviewing just a little bit for it.
What they do get on this?
What did? You'll find out. Well, technically the handbook already says, but it says for the holidays. What? What?
It's on the poster next to it.
It's on, we get, the last day of school is on a Tuesday this year, so it's a little bit different. So, it's not this week, it's not next week, it's not the next week, but it's the week after, I believe. So, we have about 15 days, we have a slightly over, I think a little bit over 2 to 3 weeks from today. We got to keep going from it. Alright, so just make a note for it, that it's just pointing out that okay, the Lewis structures, they can be written several different ways. So, for that one, with the NO3, it's just saying that the extra pair of electrons is vibrating between all three oxygen molecules. Alright, anyone have any questions about delocalization of the situation or delocalized electrons? Alright, molecular shape. So, your book's pointing out that, okay, we want to try to describe atoms as best as we can. With the Lewis structures, we can only draw them like, we can only draw them like this because this is a flat surface, but our molecules actual flat 2D surfaces, Ethan. Are molecules flat 2D surfaces or are they 3D?
To be honest, I don't know.
Alright,
Not 3D.
what makes up your desk?
Atoms.
Atoms, molecules. So is your desk 3D? What was it? Your desk is not 3D, it exists in 2 dimensions.
Yeah.
Your desk is perfectly flat.
It's flat.
Your whole desk.
It's flat.
Whole desk. Whole desk.
Not the whole desk, but it's flat.
Okay, so it has no width whatsoever.
He's playing right.
I know.
I know.
Okay, so remember, atoms and molecules make up our world, and our world has 3D substances. You exist in 3 dimensions of the idea of height, length, and width. So because of that, molecules are also 3D substances. So this is not an entirely accurate drawing of them, but I can't draw 3D very well. And so because of that, we use molecular shapes to help represent it a little bit easier with these molecule structures. So that's what your book starts talking to, and that's what your book is trying to start showing you the molecules. But since your book is also a 2D substance where it's trying to represent a 3D object, it gets a little cumbersome. That's what they're talking about. Alright, so how we draw these is you have as a lot of cases, we base it on the idea of that central atom and saying, okay, the electrons of the central atom want to get as far away from each other as possible. Why do the electrons of the central atom want to spread out as much as possible? Wait,
Because they hate the other ones.
because they what?
Hate the other ones.
You're right, why? Not really hate them, but you have our idea, they don't want to be around each other.
Because they're both negative.
Good job. So the negative electrons want to spread out from each other as much as possible. So we call this theory the valence shell electron pair repulsion. We just pronounce that Vesper because it's a bunch of letters all together and it looks kind of like the word Vesper, so that's how we say it that way, even though technically it doesn't actually spell
Is that
Vesper.
a gun call, dude?
That's what I
Wait,
said.
raise your hand, Ethan. Ethan, do you have a question? Are you distracting people in my class? Don't distract people in my class, don't distract me. Yes.
Have you ever played Call of Duty?
Very badly, yes.
Okay.
Is this important to chemistry? I have
It's
like
a gun.
7 minutes.
It'll help me remember Vesper. Was there a gun in Call of Duty that was called Vesper and Ghost?
Oh, I do
Okay, I
not
remember.
remember it. It's been way too long since I
I
tried that.
knew you said that.
Alright, we got you going. So, we call these with the idea of basing, we call the idea of basing this theory with the electrons of the central atom, the Vesper theory or Vesper model. So this is where your book is basing all of this from. So take note as we're going through it. So, the first one is tetrahedral molecules. Alright, tetra means what in chemistry? Quentin? 4. So this is the idea of you have 4 molecules bonded to a central atom. So there's 5 atoms total, so you have 1 atom in the center, and then 4 atoms bonded all the way around it in a 3D substance. We call this a tetrahedron. So this one at least makes sense because it's 4 atoms bonded around a central one. Now, they want to spread out from each other as much as possible, so they will spread out 109.5 degrees apart. In a square, what's the degrees apart between the points? Anyone know from geography? Not sorry, geometry.
We've not talked about that.
You haven't talked about like how far apart the points are? Alright, so with a you gotta stop moving, Sean.
Wait, is it 90?
Good up, yeah. So what's the idea of if you have a 90-degree angle?
I'm so smart.
So that's the idea, that's 90 degrees for it. So, in this model, since this is not a 2D surface, they're spreading out a little bit farther. So it's not the idea of they're just spreading out in a square like this. They're spreading out this way, so that way they are 109 degrees apart, because the electrons want to spread out from each other as much as possible. You don't have to memorize what's the degrees apart for them. Now, I'm just explaining it to you. So this is a tetrahedron. So make a note from that, or we call this bonding situation. Tetrahedral is the name for the shape. So just make a note for this one. So tetrahedral is the name of the shape. Alright, tetrahedron is the name of the square in geography. Just making sure of that. So we call this a tetrahedral because it's a 3D one. Alright, anyone have any questions about this shape? So again, 5 atoms with 4 bonded all the way around it. Alright, trigonal pyramidal is the next one. So a pyramid has how many, a pyramid has how many corners at the base? Alright, Ethan. 3, and then of course it has the one at the top. So for this one, we get this situation where it's like this. Alright,
A pyramid.
wait.
Sorry. A pyramid, like the Pyramid of Giza.
Hmm?
The Pyramid of Giza has 4.
That's what I
Yeah.
thought.
Okay,
You said
so 3 how many corners at the base?
Yeah, at the very
4.
base, there's 4. 1, 2,
Oh, I'm
3,
sorry. Okay, so like a regular,
Triangle.
yeah, triangle pyramid. I'm sorry. I'm sorry, I didn't wrong. I was picturing like a regular like triangle, like drawing a triangle and making it into a 3D substance. I'm sorry.
That's what I was thinking.
Thank you. Thank you, Ethan, for being on the same wavelength as me, but I'm sorry for not being clear.
Both
Alright.
of us think alike.
Yeah.
Alright, so for this one again, this is the same idea, but the idea of 3 corners, with the idea of taking a triangle and making a pyramid from it. This is the same idea. Now, this large balloon-like structure, and that's what your book is trying to show you as well, represents unpaired electrons for it. Now, these are electrons that are not locked into any one spot. I have 5 minutes, so make sure
I know,
you're still
I'm
with me.
playing my notebook.
Okay. So these electrons are not paired up and they're not locked in. So these electrons, do they like each other even though they're not locked into a pair? Chris. No. So because of that, they will still shimmy away from each other just a little bit. So they take up just a little bit more room because they're still spreading out from each other as much as they can for it. So your book gives you the example for this one where it's NH3. Gotta stop moving the chalk around. So, NH3 for this one, that you would draw it like this, But you can't see, okay, that the nitrogen still has the unpaired electrons at the top. So they're still spreading out from each other. So that's what I found yesterday whenever I was drawing this. I was drawing it as like a balloon shape because the electrons, they won't stay right here next to each other because they don't like to do that. So they will still spread out from each other as much as they can. So because of that, they will push the other electrons slightly closer together. They don't like each other either, but they're attracted to the hydrogen and the nitrogen since they're locked in, being shared, so they can't shimmy around or move that much. So they will push them slightly closer together down at the bottom. So your book points out your book points out that the angles between them is 107 degrees. Again, just slightly closer. You don't have to memorize the degrees. But if you call this trigonal, pyramidal, so just make a note, or pyramidal, so how some people say it as well. So anyone have any questions about this shape? We call this trigonal because there's 3 electrons, 3 atoms bonded to it. Alright, anyone have any questions about this? Chris, you got any questions about it? Sure? It looks like he's zoned out.
I'm here.
Alright, good. Alright, alright, angular molecule. So this name gets a little bit more confusing because they're not named with the idea of 3 or 2 or 9. This one has to do like with water molecules because if you have something like oxygen where there's 2 regions of unpaired electrons, those electrons will split up from each other as well from it. I officially lost my chart. There it is. I'm sorry. Just make sure you just learn from your mistakes.
Class.
Yeah, and make sure you learn as well, just to improve from things like from your homework, or other than that, just make sure that you just learn from it. Alright, so like for water, I'm gonna run out of space. We'll write it down here so I can still see it. Alright, oxygen starts off with how many electrons? Chris.
2.
Oxygen.
6.
6. So because of that, it will form a single pair if you time it. But it still has 1, 2, 3, 4, and then 5 was its original one, and then 6 was its original one. Well, oxygen is satisfied because it's borrowing one of hydrogen's as well, but it still has those 2 regions of unpaired electrons. And so because of that, they will push them still slightly closer together. There's only 105 angle between them, but that's because these unpaired electrons are pushing them closer together down at the bottom, because these unpaired electrons are taking more space. Now typically, we don't see the unpaired electrons, we just draw water like this, and that's probably the reason why we just draw it like this. Or typically we don't worry about the unpaired electrons, because if you're worried about the shape, this is the reason why it forms this particular type of shape for it. So wait, raise your hand. What is it?
Retarded butterfly.
It does a little bit. Last year, I think it was either last year's kids or the year before, and they memorized it, and it looks kind of like a Mickey Mouse head with the shapes for it, sort of, kinda for it. But again, whatever helps you to memorize it, that's fine for it. Alright, come up for tonight.
Don't
All right.
mess up.
Finish reading pages 138 to 100, we'll go a little bit further, probably 140. So 138 to 140. Answer on page 139, the concept review 2 and 3. Concept review 2 and 3. Alright, you're going to do application, attempt it. We didn't quite get through all of them, but you should probably be fine, but attempt it. Number 2, you're going to do A, C, E, and G, because some of them are harder, so we're going to just stick with those. Okay, so it's number 2, A, C, E, G. Alright, anyone have a question about it?
What page is that on?
It's on page 139.